So, you want to build real-time features in React. Things like live chats or dashboards that update on their own. It seems pretty simple at first, right? But the second you move from a tutorial to a real production app, that's when you find out all the little details that can go wrong. Today, we're going to walk through all those common pitfalls and get you to a place where your real-time features are totally polished and professional.
All right, so here's the game plan. First, we'll quickly cover why the normal way the web works just doesn't cut it for real-time. Then we'll look at WebSockets, which is the solution, and the libraries that make them ready for prime time. Now, the core of this whole thing will be diving deep into the integration pitfalls, the bugs everyone hits when they mix this stuff with React. After that, we'll look at a really cool trick to make your app feel blazing fast. And we'll wrap it all up with a simple playbook you can use on your own projects. So first up, before we can even talk about the solution, we've got to get on the same page about the problem. And that problem is what I call the request-response trap. It's just the default way the web communicates. Think about it like this. Standard HTTP is basically like snail mail. Your app, the client, sends a request, that's the letter, and then it just waits for the server to reply, which is fine for fetching a website. But imagine trying to have a live chat that way. You'd have to keep sending letters every second asking, "Anything new? How about now?" It's just not going to work. What you really need is an open phone line, a connection that's just always on, where the server can call you the moment something happens. And that right there is the big difference WebSockets bring to the table. And that brings us right to the technology that gives us that open phone line. Let's talk about WebSockets, the standard solution for pretty much all real-time stuff on the web today.
So what is a WebSocket, really? Well, you can think of it like a long-term relationship between your browser and the server. Once you establish it, it just stays open. And it's full duplex, which is just a fancy way of saying it's a two-way street. The client can talk to the server, and crucially, the server can talk back to the client at any time. This is the magic ingredient for things like live sports scores, collaborative Google Docs-style editing, anything that needs instant updates.
Okay, so this sounds great, and WebSockets are built right into the browser. So you're probably thinking, cool, I'll just use the native API, and I'm done. And look, you could do that, but you'd be signing yourself up for a world of pain in a real production app, because you'd be solving a bunch of tedious problems that other people have already solved for you. And this is exactly why basically everyone uses a library like socket.io for production apps. I mean, think about the edge cases. What happens when your user's Wi-Fi drops for a second? You got to write all the logic to reconnect automatically. What if they're behind some weird corporate firewall that blocks WebSockets? Socket.io will automatically fall back to another method. Did they miss any messages while they were disconnected? It handles that too. Using a library like this lets you focus on building your features, not on reinventing all this complex infrastructure. All right, now for the main event. This is where most people get tripped up. We've got our tool, but integrating this kind of persistent connection into React's world of components and lifecycles, well, it can be a minefield. And the minefield is almost always centered on one specific hook: use effect. This is the fundamental conflict, isn't it? You have this socket connection, which is a long-lived thing that should just exist outside of React's world, but then you have your React components, which are constantly mounting, re-rendering, and unmounting. Trying to make these two very different life cycles play nicely together is where all the bugs come from. So before we look at the bugs, let's look at the right way to do it. This is the pattern you need to burn into your brain. Use a useEffect hook with an empty dependency array so it only runs once when the component mounts. Inside, you set up your event listeners with socket.on. And then, and this is the absolute most important part, you return a cleanup function. And that function's only job is to undo everything you just did, using socket.off. Set up and tear down. That's the golden rule. Now, let's look at the first bug pretty much everyone writes. This code looks almost identical, right? But look closely at that return function. It's empty. There's no cleanup. So what happens? Every time this component re-renders, it slaps on a new onFoo event listener, but it never removes the old one. They just pile up. Pretty soon, one event comes in from the server, and your function fires 5, 10, 100 times. You will pull your hair out trying to debug this. And the fix is, honestly, super simple. You just have to be disciplined. The rule is this: for every socket.on, you must have a matching socket.off in your cleanup function, period. It's a contract. You set it up, you tear it down. This guarantees you only ever have one listener for that component instance, and it gets cleaned up perfectly when the component goes away. No leaks, no weird behavior. Okay, bug number 2 is a little bit sneakier. This one is all about the dependency array. See what's happening here? We've mixed our connection logic, the connect and disconnect calls, into the same effect as our event listeners. And we've put some state, foo events into the dependency array. So, what happens every single time that state changes? The entire effect runs again. It disconnects the socket and then immediately reconnects it. This is wildly inefficient. You can easily drop messages during that little blip, and you're just hammering your server for no reason.
The key here, and this is a huge takeaway, is to separate your concerns. You should use 2 useEffect hooks, not 1. The first one is only for managing the connection itself. See how it has an empty dependency array? It just connects on mount and disconnects on unmount. That's its only job. Then, you have a separate useEffect just for your event listeners. This one can have dependencies. It's totally fine for it to rerun and swap out listeners when your state changes, because the underlying connection is stable and completely unaffected. This 2-hook pattern is the secret sauce to a bug-free setup.
All right, a couple more quick pro tips straight from the trenches. First, hot module reloading, or HMR, can sometimes be your enemy here. If you're editing your main socket file, HMR might not clean up the old connection properly, leaving you with these ghost connections that cause duplicate messages. If you ever see weird behavior like that, just do a good old-fashioned full-page refresh. It often clears it right up. Second, try to avoid putting your socket listeners deep inside child components. It's better to centralize your socket logic in a top-level component or a context and then pass the state down. Why? Because if that child component unmounts, its listener goes away, and you could miss crucial messages.
Okay, so our connection is stable. We've squashed all the common bugs. Now let's level up. Let's move from just making it work to making it feel amazing for the user. We're going to do that by creating the illusion of instant speed. This trick is called an optimistic UI. Now, normally, when a user clicks a button, we show a spinner, wait for the server to give us a thumbs up, and then we update the screen. An optimistic UI completely flips that script. The user takes an action, and we update the UI instantly as if it already succeeded. We're being optimistic. The actual request to the server happens quietly in the background. From the user's perspective, it feels like there's zero latency. It's a powerful psychological win. Let's make this super concrete with a chat app example. Step 1. You type a message and hit send. Step 2. Bam! Your message appears in the chat window right away, instantly. Maybe it's a little faded out or has a tiny clock icon next to it to show that it's pending. We haven't even talked to the server yet. Step 3. Now, in the background, we fire off the socket.emit. Step 4. The server gets it, sends back a confirmation, and all we do is remove that little pending icon. And only in that rare case where something goes wrong, step 5, do we have to roll back, remove the message, and show an error. But for 99% of interactions, the user experiences zero lag. Now, you might be thinking, that sounds really complicated to manage. And you're right. Doing this from scratch used to be a huge headache. But modern data fetching libraries are an absolute game changer here. This quote from Kent C. Dodds really gets at this shift. Tools like TanStack Query, which you might know as React Query, have this pattern built in as a first-class feature. They make it so much easier to handle the temporary state, the background request, and any potential error rollback. We've covered a ton of ground here, right? We've gone from the basic theory all the way to some pretty advanced user experience patterns. So let's boil all this down into an actionable playbook that you can actually take with you and use on your next project. Here it is, your real-time React checklist. Number 1, choose the right tool. That means don't reinvent the wheel. Use a production-ready library like socket.io. Number 2, centralize your connection. Keep your socket logic in one place, not scattered all over your components. 3, master that useEffect pattern. Seriously, that 2-hook approach will save you hours of debugging. 4, think optimistically. For actions the user takes, update the UI first to make it feel instant. And finally, number 5, if you're building something with really frequent events like tracking mouse cursors, be a good citizen and throttle your updates to protect your server. Keep these 5 things in mind, and you'll be building incredibly polished, stable, real-time apps. So, there you have it. The technical challenges are solved, your connection is rock solid, your UI feels instantaneous. The how is handled. The real question is, what are you going to build with this power? How are you going to design the next great collaborative experience now that the technology is just easy? The tech is just the beginning. Now you get to go build something amazing.